Good day. So for this week 2, we are going to discuss the intermolecular forces in liquid. So last week we have identified what do intermolecular forces means and what are the different types of intermolecular forces. So in intermolecular forces, these are the forces that acts between the molecules, and we have different types. So we have dipole-dipole, hydrogen bond, London dispersion on van der Waals, and we also have another is the ion-ion. So let's go next. Let us go with the intermolecular forces in liquid. Let us study what do these intermolecular forces act in a liquid. So first, in your high school, you have identified you already know what are the different properties of liquid. So, alam na alam nyo na kung ano yung mga iba't ibang properties ng liquid kasi diniscuss na yan nung high school. Nung junior high school kayo. But this, in a senior high school under general chemistry 2, we're going to study the molecules that act on the properties of a liquid. The first one is the surface tension. Remember, what is the why do paper clips floats in water? Why do insects can walk on the water? So ito yung mga questions, bakit? Bakit kaya? So we will try to know, alam natin, yes, na they are trying to float, they can walk. So what's the reason? So is there something to do with the intermolecular forces? So let's define first. So when we say surface tension, it is the measure of the elastic force in the surface of the liquid. So it means there will be an energy required to stretch or to increase the surface of a liquid by a unit area. So manifested, ayan siya. So meron tayong mga illustrations just like this one. This is how the molecules act on a surface tension. When you try to put a water on a coin, on a single coin or a single penny, so the water usually adopts the shape. Sabi nga natin, diba, the liquid usually adopts the shape. Yes, especially here. So the coin is circular form, snow form siya. Actually, kahit hindi, diba, hindi coin. So kahit matapon lang yung tubig. So there will be a big form of water. So meron mga water droplets na tinatawag tayo. And these water droplets will look like this. So the molecules will have this kind of attraction, and the other one has a circular path that attracted to each molecules, and that is how intermolecular force is defined, right? So dito natin makikita yung attraction ng bawat molecules and how do they form as this. So it means, remember in our discussion last week, in intermolecular forces, we have identified na si molecules ay na-attract siya with other molecules, diba? So, like, for example, H2O. This is an H2O water. So, hydrogen bonds ang na-form niya. So, hydrogen bonds, the partially positive of hydrogen will be attracted to the partially negative of oxygen. And that's the reason maybe they will form like this, because they will be attracted to another like that. Okay? Kaya nagfo-form siya. Bakit nagfo-form ng ganyan? So, we will know deeper. Let's go next. So, next. In this two picture explains the plain water and the soapy water in a surface tension. So, as I said a while ago, sa coin, nagfo-form tayo ng ganito, where this will be bonded like this one, the hydrogen bonds, ayun siya, in H2O. While in soapy water, hindi nagfo-form, pero nagkakaroon ng bubbles, diba? Nagiging circle yung mga bubbles natin. Bakit kaya? Because of the presence of the soap molecule. Because the soap molecules is the barrier para hindi sila mag-attract. So, ayan yung lines na yan, yan yung soap molecules na humaharang sa mga hydrogen H2O natin na mag-bond at mag-form ng ganyan. So, it will be a form of barrier. So, surface tension, have a harder time attracting each other. So, the surface tension is reduced. Okay? So, it will be best explained why do water with a soap will form a bubbles, di ba? Nagiging circular shape siya. But when there is a force or hawakan natin, it suddenly pops. Okay? That is the reason of the surface tension in a soap molecule. Next, this one. We have here an example. Ito lagi nakikita natin pag nakakatapon tayo ng tubig, 'di ba? Nagkakaroon ng water droplets. Why? Because of these molecules, ayan siya, oh, nagkakaroon ng team up where they hold each other, and on the middle of it, the molecules were attracted to each other. So, bakit kaya? Bakit? So, it will be explained next. So, the molecules within a liquid are pulled in all directions by intermolecular forces. So, kaya tayo nagkakaroon kanina, di ba, ng upward, downward, and sideways na mga direction. Kasi na-attract nga siya, sabi ko sa inyo, into a partially positive and partially negative. And these intermolecular forces to pull the molecules into liquid. Kaya nagkakaroon ng elastic film or the skin. Just like this picture. 'Di ba? Kapag tinuloy pa na natin yung paglagay natin ng water, nang hindi mabilis yung dahan-dahan lang. Something will be formed like this, yung mas mataas kaya niyang i-hold. Kayang-kayang i-hold ni water 'yan, ganyan. So kayang-kaya i-hold 'yan. But if suddenly there will be a force, merong force na mag-act dito or magkaroon ng onting bigat sa pag-drop ng water, then suddenly the water will yung mapupuno and matatapon, di ba? So that explains how the surface tension is. So as long as they carry the attractions of its molecules, hold on to each other sila. So ayan, it's harder to move when molecules are tied together. Yes. Mahirap kasi napapalibutan siya. But when there is a force, then dissolve yan. Next, we have here a picture where it is an explanation of cohesion and adhesion in a surface tension. But what do you mean by cohesion, ma'am, and adhesion? So, cohesion by the picture itself, nakita nyo, dalawang molecules where they telling to each other of I love you. So it means it is a molecules that attracted to each other, diba? Attracted to each other, parehas molecule to molecule, that is under cohesion. And when it is an adhesion, it is a molecule that is attracted to its other stuff. So that's the difference of cohesion and adhesion. So how can we explain, ma'am, in a surface tension? Yes, very good. Since surface tension, these are the molecules, ayan siya. These molecules, it is under adhesion. Bakit? That's the reason, di ba, bakit nagfo-float si paperclip. Bakit nakakalakad si insects? So, although kahit mabilis, so baka mag-try kayo maglakad, remember, mayroong explanation regarding the weight or density. So, mas mabigat kayo, huwag na tayo umasa. So, on this, it explains the adhesion where they love other stuff. So, that's the reason nag-a-attract siya dun sa other stuff. At that's the reason hindi siya nabe-breakthrough. Hindi nasisira yung kanyang bonded. And these molecules will have the cohesion, especially dun sa ilalim. Dun explain natin kanina yung sa surface tension sa bandang ilalim part na mga molecules, that is cohesion because they attracted to each other, although in a circular pattern. So, paikot siya. So, that is under cohesion. We will know it more deeper next to our next lesson. So, next property of liquid is under capillary action. So, parang wala siya sa module nyo, but let me discuss this one. So, capillary action, it is a tendency of a liquid to rise in a narrow tubes or small openings. So, it can be under form of capillarity. So, it is a result of intermolecular attraction between solid and liquid materials. So, ito na. Anong type kaya? Cohesion ba yun o adhesion? Yung nagkakaroon ng attraction with other stuff. Okay? So, capillary action, ito yung reason bakit kapag nag-i-straw tayo, kahit isang sip lang natin, isang higop lang natin, dire-diretso pa rin yung water sa hospital. Sa hospital. So, bakit yung mga dextrose sa mga tubes, narrow tubes, 'di ba? Usually, ito yun eh. So, yung mga hinihigop nating mga tawag din? Hose. Tapos, magfo-flow na dire-diretso yung water kung saan nanggagaling. So, that explains capillary action. So, this picture explains how do molecules acted on a narrow tube. So, on the first picture, as you can see, ayan, nag-i-start pa lang sila na mag-flow up into this tube. Second, it will be piled up pataas hanggang, ayun, nakarating na siya sa taas. So, how can we explain this one? So, we can explain this one into a two capillarity attraction. So, as you can see, water and mercury. So, this one explains of the two forces, so two attraction of cohesion and adhesion. So, dalawang explanation natin dyan. So, where this picture explains, so if you try to remember in an experiment, so, diba, sinasabi ni teacher kung paano natin i-read. So, i-read natin ito. So, dito sa meniscus type niya, yan ang ating babasahin. So, itong dalawang part na picture na to explain this is the mercury and this is an of water. So, why it is different? So, because of this attraction. Si adhesion ay isa sa mga reason kung bakit nagkaroon ng ganong reaction. So, when we try to remember what do you mean adhesion, ito yung the molecules is attracted to other stuff or solid materials. So, this is the solid material, yung narrow tube natin. And this part, itong ina-arrow na to, explains the adhesion, where the molecules are attracted to the solid material, which is the narrow tube. So, nagpo-form siya ng ganyan. And that explains the adhesion. So, next, cohesion or cohesive attraction. Cohesion is the attraction between two molecules. Okay? So, hindi siya mutually attracted sila. So, present din ba sa capillary action? Yes, present din po. If this is the explanation of the adhesion, so the one that flows upward dito sa gitna, itong gitna na to, pag umakyat yung mga molecules, this explains the cohesion where the molecules are attracted to each other. 'Di ba? Kasi sa tingin nyo kung adhesion lang, dito lang yung water. Diyan lang yung water. Yan lang. 'Di ba? Pero kasi kasama siya, nagpo-form siya ng ganyan. So, that is process of cohesion. So, this one explains the cohesion. This is the adhesion part. Ayan. Where they are attracted to the solid material. Ayan, nakaline siya. While this is the cohesion where the molecules are attracted or mutually attracted to each other. So, sabi dito, if mas malakas or greater yung force ng adhesion sa isang liquid, so it will form usually a concave, just like the water in a glass of container. So, anong itsura nun? So, later I will show you. So, if the mas greater naman ang cohesive forces, mas malakas kaysa kay adhesive, so it will form a convex, just like a mercury. So, like this one. Ayan siya. So, nag-form ng ganyan, nag-form ng concave, and convex. So, that explains the property of the liquid of cohesion and adhesion. So, another picture explains cohesion and adhesion. This one, holding the rope. Sorry. Oh, wait po. So, a while ago, dun sa picture, sorry na baka. So, the rope is holding, the molecule is holding to the rope, and that is adhesion. And the one holding to each other is the cohesion, just like this one. Ayan po. This one is the adhesion, and this one is the cohesion. in a capillary action. Another example of this. So cohesion is the one that causes the formation of the water drops when it rains. So ito, kaya nagkakaroon ng water droplets. Kaya nagkakaroon ng water droplets. Ayan, that is an example of cohesion. While in adhesion, these are the causes that drops to cling to other surface, and that's the reason hindi sila nag-i-stay silang ganyan. Diyan. Nag-i-stay sila nakadikit dito sa plant. 'Di ba? Unless humangin, galawin, 'di ba? So bumigat, so mawawala sila yung pag-attract nila dun sa plant na yan. So, next tayo. On our next property of liquid is under viscosity. So, we all know this one. Viscosity is the resistance to flow. So, alam natin ano yung best example ng viscosity. It's ketchup. So, alam natin ng ketchup. So, sabi dito, the greater the viscosity, the slower the liquid. Mas malakas ng viscosity, mas mahirap mag-flow si liquid. So, ano yung example natin? Like, ketchup, honey, Mang Tomas, mantika. So those are an example of a liquid having its viscosity. Actually, lahat po ng liquid ay may viscosity. The question is how much or gaano kadami or gaano kalaki yung viscosity. So ulitin ko, lahat po ng liquid properties ay may viscosity. The question is gaano kalakas o gaano karami yung viscosity amount niya. Later on, we will discuss. So, viscosity is expressed in units of centipoise. As I said a while ago, sabi ko nga, lahat po ng liquid particles ay may viscosity. Even water. So, di ba? So, ibig sabihin pala, kapag nung junior high school po kami, ma'am, pag in-example po namin sa viscosity is water, pwede po. Pwede, di ba? Kasi all liquid particles has its viscosity. But the question is, sino yung merong much greater viscosity? So, hindi na lang siya in-explain. So, in this senior high lang na-explain siya. So, water has viscosity of 1 centipoise, or it can be 0.001 Pascal per second at 20 degrees Celsius. So, imagine may viscosity amount si water, yun nga lang 0.001. So, it still has its viscosity. So, next. So, what do you mean by centipoise, ma'am? Centipoise is the amount of force necessary to move of a layer in relation to another liquid. So, ito yung amount na need niyang makapag-move para kay viscosity. So, for other information, so may tinatawag tayong poise. It is the dynamic viscosity, usually expressed as Cp. So, yun yung centipoise, C, small, and capital P. So, the man behind this one, I mean the person behind this one, is Jean-Louis Marie Poiseuille in the year of 1838. So, actually, she discovered it while she has having her study in blood flow. So, napansin niya, it is not like as water. So, that's the reason nagkaroon siya. So, the analogous unit for international system is Pascal per second. Kaya sabi ko kanina, may Pascal per second. Any unit, gamitin natin basta Pascal per second, or centipoise is the same. So, water has viscosity of 0.0089, same with 0.001. So, these are example of liquids with its viscosity. So, we have acetone, benzene, carbon tetrachloride, diethyl, ether, ethanol, glycerol, and water. So, among this viscosity amount, so which of these liquids has a higher viscosity? So, automatically, the answer, ma'am, it's glycerol. Kasi among this, wala siyang times 10 raised to negative something. So, glycerol. Now, I will be giving you the molecular structure of water and glycerol. So, can you tell why glycerol has higher viscosity than water? Aside from, ma'am, kasi mas mabilis mag-flow si liquid based from its molecular structure. So, look at this one. On this part, it is the glycerol. and this one is the water. So among from this molecular structure, bakit kaya may viscosity, mas mataas yung viscosity ni glycerol kaysa kay water? Think of it, based from its structure. Do you know why? Maybe you're right. So because it has great number of OH group. And remember, in intermolecular forces, si hydrogen bonds, so hydrogen and oxygen, is greater force, mas great yung force niya. So unlike this water, so HOH siya. From this, there is a presence of OH. And sabi dito, the larger the number of negative OH group, so it will form more hydrogen bonds, making this intermolecular forces stronger than those water. So mas strong ang intermolecular forces, mas mataas yung resistance niya to flow. Okay? So kasi mas malakas yung intermolecular forces nila, yung kapit nila sa isa't isa. So mahirap silang pag-breaking, mahirap silang paghiwalayin. So yun yung yung reason bakit mataas yung viscosity niya. So unless there will be a great force that will act para mapaghiwalay sila. So let us try to identify what is glycerol. Si glycerol, another name is propane 1,2,3 triol. It can be a glycerine, propanyl 1,2,3. Ayan. So another chemical formula for this chemical formula is C3H8O3. So si glycerol po, usually it is present on experiment. So lagi siyang inire-request kung kayo ay merong III or research, si glycerol ay isa sa mga hinihinging chemicals sa school. So it is a polyol compound, it is a colorless, odorless, and sweet tasting and non-toxic. Okay, this is the glycerol. So in your module, I have given you the copy of this picture where you can see a viscosity and a different liquid. Yan. So yan po yung different liquid natin: water, milk, oil, light syrup, heavy syrup, chocolate, and its molecular structure. Ayan po siya. So mas thick yung bonds pagdating dito sa chocolate syrup. So mas thick, ibig sabihin mas malakas yung bonds nila, mas strong yung kanilang bond kaysa sa iba. So mas mahirap silang paghiwalayin kaysa sa iba. If we are in a normal setup, we will going to have a experiment using a marble and with different sample of liquids, and we will try to measure how fast do this marble will reach when we drop until the marble reach the bottom. So but because we're in a pandemic, we cannot identify. So usually dito natin ma-identify yung viscosity ng ibang liquid. So mas matagal bumaba si marble, mas strong yung intermolecular forces, mas high yung viscosity ng liquid na yun. So more hydrogen bonds, higher viscosity. Let's skip this one. So the size of the molecules, the larger the molecules, so nagkakaroon ng greater viscosity compared to non-polar substances. So na-explain nila sa unang picture, mas malaki yung mga molecules, yung interaction nila, mas stronger yung bond sa isa't isa. So liquids that have strong intermolecular forces have higher viscosities. Totoo naman, di ba? Than those have weak intermolecular forces. So mas strong na intermolecular forces, mas mataas na viscosity. So, this one. Viscosity, ito yung sinasabi ko makakapaghiwalay sa kanila. Sa strong bond na meron sila. This is so-called temperature man. So, the temperature. So, viscosity decreases as temperature increases. Mas mainit, mas kaya niyang i-break yung forces. Okay? Kaya niyang paghiwalay yung molecular bond na meron sila. Okay? Their intermolecular forces through its temperature. So an example of this is the honey syrup. In a normal temperature, honey syrup is very thick, napakatagal, 'di ba? Mag-flow. Pero kapag pinesent natin siya sa init, sa heat, so it will become a liquid. Pero apparently kapag itong honey syrup na to is na-meet niya naman yung temperature natin, lumamig, na-lose niya yung kinetic energy coming from the flame, so babalik ulit siya sa pagiging viscous niya. Okay? So, temperature, pwede rin i-add natin yung amount. Just like in the ketchup, pag konti na lang ketchup nang ginagawa nyo, dinadagdagan nyo ng tubig para masimot man lang, di ba? Kasi sayang naman yung ketchup. So, it somehow decreases the viscosity. Somehow decreases the viscosity. Kasi, not all, hindi naman lahat. Kasi kapag, di ba, pina-flow na natin si ketchup, di ba, may ibang liquid na hindi napapasama, namimix dun sa ketchup. Okay? So, for this vapor pressure, we will talk about this for the next video kasi napakatagal na at matagal ko rin itong aantayin bago ma-upload. Thank you for listening. So, medyo matagal-tagal po talaga ang explanation dito sa mga under General Chemistry 2. But don't worry, kung computation ang gusto nyo, malapit yung mga 3 lessons, 4 lessons lang. So, lalabas na ang computation. So, thank you for listening. So, let us just wait for the next video to be uploaded for the vapor pressure and the boiling point. So, dalawa na lang siya. Medyo mahaba na lang ang explanation nito eh. So, thank you and God bless. So, for more questions, you can directly ask me para nagkakaintindihan tayo. Okay? Good luck. God bless.